everyone, welcome to another video. Now today we have this nice nuclear physics question, and the question reads: the magnetic flux within a stable orbit in a betatron changes at a constant rate of 15 Weber per second. What will be the energy of an electron which undergoes 10 to the 6th revolution? So now, what is betatron? Betatron is just like what we call a particle accelerator. Yeah, it's a particle accelerator. And this particle accelerator produces fast-moving electrons known as beta particles, because we know that beta particles are fast-moving electrons. Okay, so now we are given here that the magnetic flux within a stable orbit in a betatron changes at a constant rate of 15 Weber per second. Okay, so that means we're going to apply the Faraday's law. Now according to Faraday's law, we know that the EMF induced in a single coil, because this is all about a single coil, it is changing at a constant rate. Yeah, so that means the EMF induced in a single coil will be equal to the negative rate of change of the magnetic flux. Now when we say single coil, okay, according to according to according to according to Faraday's law of induction, according to the Faraday's law of induction, now we have induced EMF, the induced EMF in a single coil. The induced EMF in a single coil is equal, okay, the induced EMF in a single coil is equal to the negative rate of change of magnetic flux, okay, linking the coil. Now we can express this mathematically as follows. That is, now we have the induced EMF. This is the induced EMF. Okay, we have the induced EMF. Okay, so then we have the what? The magnetic flux. That is the change in magnetic flux with respect to time. Okay, this is the flux change, that is change in magnetic flux over what? Over time. So in this case, since we have the EMF induced is in a single coil, that is the EMF induced in a single coil. So that means for a single coil, the number of turns will be what? Will be 1. And we know that from Faraday we have the induced EMF to be proportional to the what? To the induced EMF is equal to negative rate of change of magnetic flux, okay, multiplied by number of turns. So the number of turns in this case is what? Will be 1. Now, the negative sign indicates the direction of induced current. So we're going to neglect the minus, that's the negative sign in this case, in this calculation. So since the magnetic flux is changing at a constant rate, then the induced EMF in the coil will be what? 15. Okay, that is, it will be 15 volts. That is, since the magnetic flux is changing, okay, at a constant rate, okay, at a constant rate, the induced EMF will be 15 volts. So that means the EMF will be what? 15 volts. So this is very important. Remember, we want to calculate the energy of an electron which undergoes 10 to the 6th revolution. So first of all, let's calculate the energy on an electron, okay, per 1 revolution. Yeah, the energy on this on the what that's on an electron per one revolution. That is energy on an electron, energy on an electron per revolution. So the energy on an electron per revolution would be E, okay, equals to the charge, the magnitude of the charge on the electron multiplied by the what? Multiplied by the induced EMF. Multiplied by the induced EMF. Now, don't forget that E, the value of E is 1.602, okay, multiplied by 10 raised to the what? Negative 19 coulombs. And then we have the induced EMF to be what? To be 15 volts. So the energy, okay, that is the energy on an electron per one revolution will now be equals to 1.602 times 10 raised to the what? Negative 19 multiplied by 15. Okay, so that will be, all right, so we have 1.602 multiplied by 15, and that's 24.03. So the energy per revolution, okay, that's energy per revolution. The energy per revolution, energy per revolution, energy per revolution will be equals to 24.03 times 10 raised to the what? Power of negative 19 joules per watt revolution. And that will be 2.403 times 10 raised to the what? Power of negative 19 joules per watt revolution. Okay, so this is the energy per revolution. That's energy per revolution, which is in joules per revolution. So now, so because we are giving 10 to the sixth revolution, so we now need to find the energy in joules, okay, and that will be the energy in joules, that is energy. So to calculate energy in 10 raised to the sixth revolution, not per 10 raised to the sixth revolution, so that means the energy in joules, okay, in 10 raised to the sixth revolution, so that will be this value. So that means the total energy, okay, the total energy, that is ET, will be equals to energy per revolution multiplied by 10 raised to the sixth revolution. So that will be, the total energy will be this value, 2.403 times 10 raised to the what? 10 raised to the, okay, this will be 18. This will be 18 joules per revolution. That will be negative 18 joules per revolution. Joules per revolution, then multiply by 10 raised to the power of 6 revolution. So this will cancel out. So when we combine this, so the total energy will then be 2.403 times 10 raised to the, now we have negative 18 plus 6, and this will be in joules. So the total energy will be 2.403 times 10 raised to the power of what? Negative, that's 12 joules, negative 12 joules. All right, so now what will be the energy of an electron which undergoes 10 raised to the sixth revolution? So we need to change or convert this energy value from joules into mega electron volts. Okay, so this is important. So we need to convert, that is, convert the total energy, that is ET, okay, into, that is, convert it into what? Into mega electron volt. Now we know that 1 mega electron volt is 1.602 times 10 raised to the power of negative 13, negative 13, negative 13. Okay, so this will be 1 point, so it's going to be in mega electron volts per joule. So this value will be used to multiply this value. So we have the energy, okay, the total energy in mega electron volts. The total energy in mega electron volts will be 2.403 2.403 times 10 raised to the power of negative 12 multiplied by, okay, this will be divided, okay, it will be divided, this will be in, so this is in joules, okay, so we divide it by 1.602 times 10 raised to the power of negative 13, and this will be in joules per mega electron volt. So this will become, the total energy will be, the total energy will be, yeah, the total energy will be, we have 2.403 divided by 1.602, and that's 1.5. 1.5 times 10 raised to the what? To the power of negative 12. Okay, now I'm going to add the power, that is the exponent of the one under, that's 10 raised to the power of negative 13. It will be added to 12, so that will be plus 13. So joules will cancel joules, so the unit will be in what? Mega electron volts. So the total energy, which is what would be the energy of an electron which undergoes 10 raised to the sixth revolution. So that will be 1.5 times 10 raised to the power of 1 mega electron volt, and that would be okay, that would be 15 mega electron volts. So that is the energy of the electron which undergoes 10 to the sixth revolution. The noblest pleasure is the joy of understanding. Bye bye.